Welcome to Brain Vision.
So here for part A, we can use the same analysis from problem 51 for the no friction case. So here, no friction case. From problem 51. We can say that the acceleration would then be equal to the mass of block B minus the mass of block A. This would be divided by mass of sub A plus mass sub B plus I over R squared multiplied by a factor of G. This would be equal to mass of block B minus, we can simply say mass of sub B minus mass of A divided by m sub A plus m sub B. Then we're going to substitute for the moment of inertia. So 1/2 times m sub P R squared divided by R squared. And then keeping the factor of G. At this point, we can say that the acceleration would then be equal to mass sub B minus mass sub A, keep that factor of G, and then divided by mass sub A plus mass sub B plus 1/2 times m sub P. At this point, we can solve, so this would be equal to 3.80 kilograms minus 3.15 kilograms divided by 3.80 kilograms plus 3.15 kilograms plus 1/2 of 0.80 kilograms, and then again keeping that factor of 9.8 meters per second squared. And we have that the acceleration is then equal to 0.867 meters per second squared. So for part A, this would be our acceleration. Again, this is the no friction case. For part B, now we have a frictional torque present, so friction present. And we can simply modify the equation from part A. So we can say that the sum of the torques is going to be equal to the force tension sub B times R minus force tension sub A times R minus the frictional torque. This is going to be equal to the moment of inertia times the angular acceleration, or the moment of inertia times the tangential acceleration divided by R. So we can say that m sub B G minus m sub B A multiplied by R minus m sub A G plus m sub A times the tangential acceleration times R minus the frictional torque would be equal to I times the tangential acceleration divided by R. And so we can say that then the frictional torque would then be equal to R times m sub B minus m sub A times G minus m sub B plus m sub A plus I over R squared times the tangential acceleration A, close parentheses. This would be equal to R times m sub B minus m sub A G minus m sub B plus m sub A plus 1/2 of m sub P times A. And essentially the acceleration can be found from kinematics. So V final equals V initial plus AT Therefore, A would simply be equal to V final minus V initial divided by T. This would be equal to negative 0.20 meters per second divided by time of 6.2 seconds. This is giving us negative 0.03226 meters per second squared. And then the frictional torque could then be solved. This is going to be equal to 0.040 meters multiplied by 0.65 kilograms times 9.80 meters per second squared minus 7.35 kilograms multiplied by negative 0.03226 meters per second squared. And we get that the frictional torque is going to be equal to 0.26 Newton meters. And this would be our final answer for part B. That is the end of the solution. Thank you for watching.